I wanted to close out today with just a little discussion of for loops. You'll be working with arrays, so they're likely to pop up. So let's say we wanted to write a function that returns the sum of an int array. So the obvious approach, if we're just using the basic loops we've seen so far in 61B, we would use a while loop. But a more common approach would be to use a so-called for loop. Okay? So I'll just describe them side by side, since I know many of you guys have already seen these. So a while loop, if we wanted to sum the elements of an array A, we'd create an array index, set up here a sum, and then say as long as the index is less than the length of our array, we'll increment our sum by that current element of the array, iterate or increment the index, and then finally return the sum, right? So a for loop, well, what's that all about? Well, an observation was made by early programmers that often loops look like this, right? You had an initialization, a check, and an iteration. So to make code more compact, a special little construct here was created where you do the initialization, check, and iteration all specified on one line. And how it works is each time through the loop, the first time through the loop this runs, then a check happens, and at the end of each time through the loop you do this iteration step. And then you come back, do the check, repeat the thing, iterate, right? So it just basically goes from check, actual operations inside the braces, then iteration. Okay. So that's a for loop. And if you haven't seen these before, if you're one of the people that haven't, try it out. There's some documentation here you can check out. But basically, this code you can think of as just shorthand for this. And yeah, it's a little awkward because we have these 3 statements on one line, but you get used to it, and eventually it feels native. There are also many other ways that one can do summing, say, items in a list. So here we have the for loop we just saw. But there's also, for example, here an alternate way, which uses a so-called enhanced for loop in Java. So in this case, this is like the for loop that you may have seen in Python, where I can say, okay, for every integer x that's in A, that's the way you read it, say the sum equals sum plus x. So in this case, A is the array of numbers, and you can think of x as it reincarnates itself repeatedly as each element of the array. So say our array is 0, 1, 2, 3. The first time through the loop, x will be 0, then it'll be 1, then 2, then 3. Okay? And again, if you haven't seen that, well, it's one of those things that isn't really worth lecture time, but I wanted to bring it up so you can look it up later if you think that this code looks nicer than this code. It's also possible to use recursion to work with arrays. So if you want to sum over an array, just a reminder that there's no slice notation. There's no way to say, give me just the last, say, n-1 items. Can't do it. However, you can still do recursion on arrays, even though there isn't a dot tail like there was in int list. And how we're going to do it is with creating helper methods. Like here I have one called private static int alt sum2. What this one does is it acts as a helper for this recursive method. And the big picture, the key insight, is what this function does is it sums over the array A starting from position K. That's what makes the magic work. And then there's also here awful sum. So I'll see novice programmers occasionally try and do cute things like this where they say, oh, well, there's an increment, and I happen to know that you can separate statements by commas, and they'll both run over here. So what if I do sum plus equals I plus plus, and then just put a semicolon here, basically saying there's no work for the for loop to do because everything's done on one line, right? This will technically work, but it is terrible code. It's hard to read, it's bizarre, and yeah, it's cute, but it's actually not better than this. It might seem better than this because you're like, ooh, it's all in one place, but it's not, I promise, right? The important thing is readability. This isn't going to be more efficient just because you didn't use as many lines. Okay? I guess if you're, I don't know, trapped on the side of a mountain and you're really bored and you're carving out code and you want to have it all down there and you are really short on vertical space and you need this to preserve your sanity, in that circumstance I'd say this is okay. But if you're not really short on vertical space, please don't do that. All right. So one way we might summarize this, this approach, this is kind of the Mario of approaches, right? He has the average amount of speed, acceleration. If he gets hit, he recovers at a normal rate. Here we have our Mega Man. So Mega Man has many different tools in his arsenal that he can use, and it's good to be aware of all of them. Here we have more of a Bodhisattva kind of, you have connections to the thing beyond this universe, and you can crush dragons with the power of your mind, right? It's recursion. It's very deep. It's beautiful. So you may find that you like writing code like that. But I ask that you please do not do this, right? While technically this works, there's really no reason to do it. All right, that's it. See you next